Okay, so remember last time we did some annuity kind of idea stuff? Let me just give you the formula because I'm losing my voice. So the present value of saying present value and I mean future value, right? So the future value of an annuity is given by the formula M times giant parentheses 1 plus R over N to the NT minus 1 over R over N. Okay, so let's interpret for a second. This guy is what?
Amount? Future.
Yeah, that's the amount, that's the future value. Okay. What's M gonna be? Yeah, but annuities don't really have an initial amount, right?
Is that how
So
much
you
you're
guys-
putting in every month?
Yeah, good. So this is how much you're putting in kind of
Or monthly, yearly, how
but
much
it-
you're doing?
Yeah, it doesn't have to be monthly, right? So this is your payment amount. Right, and you guys all remember that an annuity is made by kind of put a certain amount of money aside every month or every whatever. So there's my payment amount, right? That's the amount I'm setting aside. What's R gonna be?
The rate of interest?
Yeah, that's gonna be the interest rate. That one shouldn't come as a huge surprise. How about N? What's N?
Number of compounds per time.
Yeah, that's gonna be, so it's a little bit confuzzling. Okay. And I say this is confuzzling because I'm a little bit sick, so I'm a little bit off. So I'm gonna say this as carefully as I can. N is the number of payments you're making in a year.
Yeah.
Okay, now that also has to agree with the compounding period.
Which is T.
What I mean by that is if you make 2 payments in the same compounding period, they may as well be 1 payment. You guys all see that?
You say it one more time.
If you make 2 payments in the same compounding period, they may as well be the same payment.
Okay.
So if you're paying into this thing monthly, but it only compounds twice a year, right? You may as well add up all 6 of your half-year payments that all get compounded together and call them 1 payment. So that's the confuzzling part. Your book doesn't really mention this, and I'm only mentioning it because it was confusing to me. Okay? So this number of payments in a year and this thing have to be on the same kind of time scale, right? So if there's 12 payments in a year, these payment amounts have to be monthly. So really this payment amount is kind of per T over N, right? Or sorry, per year divided by N. Guys follow that? All right, let's see. So what else did I need? There's one more variable, right? T. So what's T gonna be? Yeah, that's gonna be the sort of number of years or whatever going on here. Cool? Good? Cool? Questions? Blanks? Issues? Okay, now, just to confuse the bejesus out of you, I'm going to note that this is an ordinary annuity that I've just given you. And this differs from a annuity due by when you make the payments. Okay? So, on this ordinary annuity, you make the payments at the end of each period. Cool. Ordinary means payments are made at ends of periods. I'm going to just throw the other formula up here quick, which is for the annuity due. And it's very, very similar. And I'm not going to require that you know the annuity due formula. I just want you to know there is a difference. Okay? So the annuity due is the monthly times this basically same thing, 1 plus r over n to the nt, and then we add 1 because we're compounding that payment every time. And then you subtract 1 again and divide again by this r over n thing, and then we're going to subtract m off the end. Otherwise, things mean exactly the same things. You guys cool with this? This just counts, right? Whether you earn interest on that thing at the beginning or whether you don't earn interest on your initial statement, on your initial payment. Does that make sense? Probably not. Maybe. There's mud. Okay, so on this one, I'm going to put my payment in right at the end of the compounding period, so it's not going to earn interest. So on this one, my first payment doesn't earn interest until it's been in there for a whole payment period, right?
Yeah.
On this one, right, my first payment earns interest in the period that I put it in, because I put it in at the beginning of the period. You guys see that? So it's sort of this, like, here are your compounding periods, right, going kind of on in time. If you put money in here, then this earns interest, right? If I put the money in here, right,
Just get interest on that next period.
then I'll start getting interest the next period. You guys see that? That's all the difference is. It's just when did you start this clock? You guys cool with that?
Why is that? Say your voice. It's okay.
Most people do this anyway. There is another way to organize. It's this. The only thing it differs by is when you write the geometric series down for this one, there's one less power. So if you want to get to that one, you just factor a power out. It's all in that geometric series formula. I'm going to just let you guys work with ordinary annuities. But I want you to know that if you change when the payment's made, you have to look up the different formula. Cool?